Hello, sixth graders. Welcome to our next math lesson. Today we're looking at lesson 113. There's two parts to today's lesson. One of the parts is entitled Adding and Subtracting Mixed Measures, and the second part is going to be multiplying by powers of 10. And our math lesson for today is going to begin on page 592. Now, as we introduce this lesson, we're going to talk about what exactly is a mixed measurement or mixed measures. Measurements that include more than one unit of measurement are called mixed measures. So an example of that, if we say that a movie is an hour and 40 minutes long, then we see that we've used a mixed measurement because this right here tells us two different measurements. There's an hour and there's also a minute, okay? If you were to go to someone and tell somebody, what's your height? And they said, well, I'm 5 feet to 4 inches. That would be another example of a mixed measure because you have a measurement that has, or a label that has two different measurements on it. There's feet and there's inches. So whenever you go to subtract and add mixed numbers together, those mixed measurements together, you may need to convert one of the units to another one. You may have to borrow, or in some cases, you may have to make it smaller or bigger, whatever the case may be. Back in lesson 102, we did add and subtract some mixed measurements, and those involved pounds and ounces. There were 16 ounces in a pound. So in this lesson, we're going to be adding and subtracting other mixed measures, not necessarily talking about pounds and ounces, but maybe hours and minutes. So let's take a couple of examples of what I'm talking about. So our example that we have here says the hike from the trailhead to the waterfall took 1 hour and 50 minutes to get there. It took 1 hour and 15 minutes. The return trip took 1 hour and 40 minutes. So 1 hour and 40 minutes it took. Altogether, how many hours and minutes did they hike? So this sounds to me like I have an addition problem. There's a one-way trip that took 1 hour and 50 minutes, and then there's a return trip that took 1 hour and 40 minutes. So what I'm going to do is, you'll notice here, I'm going to add those together. So I'm going to take 1 hour and 50 minutes and 1 hour and 40 minutes. And I'm going to add the minutes first, and then I'm going to add the hours secondly. So I'm going to start off by adding 50 minutes plus 40 minutes. And through my years of mathematics, I know that 50 plus 40 is 90 minutes, okay? But here's where we have a problem. Because whenever you look at a clock, you notice that anytime you have a number that's less than 60, that's what we display. Anytime this number here is either 60 or more, this number here needs to be simplified. We need to make this smaller. So what we're going to do is we're actually going to take 60 minutes out of this. Okay, we're going to take 60 minutes out of here. So like I said, sixth graders, anytime this number here is 60 or more, we have to take 60 out of it. So what I'm going to do is I'm going to take 60 out of this. So I'm going to just cross the 90 out. I'm taking 60 out of it. So I'm taking 60 out of it, taking 60 minutes out, and that's going to leave me with 30 minutes left over. Okay, so now I got 30 minutes. But now that I took that 60 minutes out, I'm going to convert that 60 minutes to 1 hour, and I'm going to add 1 hour to this column up here. Okay, so all I've done so far is I've taken 50 minutes plus 40 minutes, which is 90 minutes. This is too high of a label, so I'm going to take 60 minutes out of that. I have 30 minutes left over. I'm taking that 60 minutes that I took out, and I'm going to add that to my hour because I know that 60 minutes is equal to 1 hour. And now I want to add my new numbers for my hours category. I've got 1 hour that I created plus the 1 hour here plus another hour here. That would give me a grand total of 3 hours. So if I was going to add 1 hour 50 minutes and 1 hour and 40 minutes, that answer would be 3 hours 30 minutes. I don't want to write 2 hours 90 minutes because it just sounds weird anytime you have a minutes that's more than 60. So you want to try to narrow that down, and that's what today's lesson's about. Sometimes when you add these numbers together, you may have to narrow them down. Sometimes when you subtract these, you have to also borrow as well. Now I already noticed on this side here, unfortunately, ignore this. This should be a minus sign, so I'll go back and change that a little later. But here's my problem. It says to measure his vertical leap, Tyrone first reaches as high as he can against a wall. So he's standing up against the wall and he reaches as high as he can. And he can reach 6 feet 9 inches just by standing still. Then he's going to put a little bit of chalk on his fingertips, and then he tries to jump as high as he can against that wall, and then he slaps the wall. The top of the chalk mark reads 8 feet 7 inches. So then the question is, how high off the ground can Tyrone leap? So 6 feet 9 inches was his starting height. 8 feet 7 inches was the maximum height. We need to subtract these two to figure out how high he actually can jump off the floor. So I'm going to subtract my inches and I'm going to subtract my feet. Now already I see that I have a problem here, because if I go 7 minus 9, I can't do that. You can't take a smaller number and subtract a bigger number from it. So what I'm going to do is I'm actually going to borrow from the feet. So what I'm going to do is I'm going to borrow 1 foot here from 8, and now I'm left with 7 feet. And now I'm going to take that 1 foot and I'm going to convert that 1 foot into inches. And hopefully we remember that 1 foot represents 12 inches. So what I'm going to do is I'm going to take this 12 feet and I'm going to add it on to the 7 that's already there. So I have to convert feet to inches, and I know that there are 12 inches in 1 foot. So I'm going to add the 12 inches onto the 7 inches. Now this is going to leave me with 19 inches. Now I can go ahead and subtract. Now be careful, because some people might be tempted to cross off the one here and then just add 10 onto this like you've been doing with a lot of mathematics. But understand, there aren't 10 inches in a foot. There are 12 inches in a foot. So we want to make sure to add 12 here and not just 10. Okay, so I take the 7 plus 12, I got 19. Now I'm going to go ahead and subtract my inches. I have 19 inches, and now I'm going to subtract 9 from that. That's going to give me 10 inches that are left here. Now I'm going to go back and subtract the feet. So I have 7 feet minus 6 feet, and that's 1 foot. So when it says, how high off the ground can Tyrone leap? We're going to say he can leap 1 foot, 10 inches. By borrowing here, making this number bigger, I got to borrow from this, make it smaller, but I got to make this bigger by adding 12 on here because there are 12 inches in 1 foot. Okay, so you may have to do some problems that are like to say, we may have to do some converting. If you add them together, you may have to make this number smaller. If you're subtracting them, you may have to borrow from here, but make sure you add the correct number onto the second column here. Okay. The other part about today we're going to talk about is multiplying by powers of 10. So when we multiply by powers of 10, actually multiplying by powers of 10 is actually a fairly easy thing to do. When we multiply by powers of 10, it actually does not change the actual digits you start with. The only thing that's going to change is the place value of where the digits are located. Okay, so let me repeat that. The digits themselves will not change. Just the place value is going to change. And we can change the place value by simply moving the decimal point to the number of places that are shown in the exponent. The exponent's going to be really huge. Okay, so for example, I have this problem here, 1 2/10 times 10 to the 3rd power. And we're going to write this in standard notation. Now, in case you don't know what standard notation means, standard notation just means write the number answer. It's a fancy way of writing write the number answer. Okay, so in order for us to do this, we're going to simply just move the decimal place 3 places. And the reason why we're going to move it 3 places is because the exponent is a 3. So we're going to move this 3 places to the right, and we're going to move it to the right because we want to make the number bigger. And by doing so, we're going to create some empty places. And if there are any empty places, we're just going to fill those empty places in with zeros. So here's my initial problem, 1 2/10. I'm going to multiply that by 10 to the 3rd power. Okay, we recognize that the exponent is 3. So this exponent 3 is going to tell us how many places to move the decimal to the right. So here's where the decimal started. And over here, you notice what I did is I drew 3 loops. 1, 2, 3. Now this is where the decimal point needs to go now. And by doing so, there were 2 empty spots here. And in these 2 empty spots, I'm going to put a 0 here and a 0 there. So I put a 0 in each empty spot that's been created. And so by doing so, you should see now that my final answer in standard notation is going to be 1,200. So notice the digits themselves did not change. I started with a 1 and a 2, and in my answer, I still had a 1 and a 2. The only thing that changed was over here, the 1 was in the ones place. Now the 1 is in the thousands place. The 2 was in the tenths place. Now it's in the hundreds place. So the digits don't change. Those should stay the same. Just where you move the decimal is going to change, and the exponent will tell you how many places to move that decimal to the right. All right, let's take a look at a couple of examples together. So we're going to write these answers in standard notation. And again, just as a review, standard notation just means write the digit answer. All right, so notice I don't have any exponents here. So I'm going to go ahead and create some exponents. Let's say this one is to the second power. Let's say this one's to the third power, and this one is to the fourth power. Okay. So now we have 6 and 2/10, and the exponent is a 2. All right, the exponent is 2. That means I'm going to move this 2 places, and visually I'm going to do that 1, 2. Notice there's an empty gap here, so I'm going to put a little 0 there. And so when I do that, I should see that my answer is 620. That'd be in standard notation. Do the same thing over here. I have 1 7/10 times 10 to the third power. Well, the exponent is 3. This right here tells me how many places to move the decimal. So I'm going to move it once, twice, 3 times. There are 2 open gaps here, so I'm going to go ahead and put a 0 in that open gap and put a 0 in that open gap. And now we should see that my answer is 1,700. Okay, go ahead and put that comma there. Same thing over here. I have 9 and 9/10 times 10 to the fourth power. The exponent is a 4. So that's going to tell me I'm going to move this decimal place 4 places to the right. I'm multiplying. I want to make them bigger. 1, 2, 3, 4. Notice that there are 3 gaps. I put a 0, 0, 0. I should see now that my answer, I have the 9 and the 9 with 3 zeros behind it. So the answer in standard notation is going to be 99,000. Now, sometimes you'll see numbers that are written in letter word form, and we got to write these in standard notation. So, for example, I have 500 million. 500 million. Well, if I was going to write 500 million, I'd write a 1 with 9 zeros behind it. But since I'm doing half, hopefully we recognize that 500 million is going to be 500 million, right? Because I don't want to have, if I wrote billion, normally I would have a 1 with 9 zeros behind it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is what 1 billion would normally look like. But I want half of this. So it's like I'm going to take this and simply just divide it by 2. So I'm going to cut that in half. And by doing so, I can get rid of this and just write a 5 here. And so my answer here should be 500 million. 500 million is going to be my answer. That's how I'd write that in standard notation. Here I have 1.5 million. 1.5 million. Well, I already know that I have 1 million. So I should have a 1 in the millions place. And this 0.5 means I have a 500 million. That would be the same as 500,000. So I need to make sure I have a 5 in the 100,000s place. And then I'm going to go ahead and make sure I put zeros everywhere else. I'll go ahead and put my zeros everywhere else. And I put my comma there. And so this would be an example of 1,500,000. That's the same as 1.5 million. Notice the 1 and the 5 are right next to each other. There were no zeros in between here. I didn't put any zeros in between there. Those numbers are still right next to each other. Kind of like up here. The numbers are still right next to each other. The 9 and 9 were right next to each other. The 1 and the 7, the 6 and the 2 here, the 1 and the 5 are next to each other. Same for over here. I have 4.5 billion. It's going to look very similar to this one over here. The 4 and the half will be right next to each other. So I already know that 500 million is 500 million. I already know that from this over here. So if I'm writing 4.5 billion, well, I need to have a 4 in the billions place. And now I'm just going to write 500 million behind it. So I put a 5 with a couple of zeros, another comma, make sure I put a commas here, another 0 there, some more zeros. I'll go ahead and put 3 more zeros here. All right, so this is my thousands place, my millions place, and my billions place. So this 4.5 billion will be the same as 4,500 million. Again, the 4 and the half are right next to each other, so those don't change. Okay, so this is how you'd write those in standard notation. All right, so I hope this helps you understand how to add and subtract mixed measures, as well as multiplying by powers of 10. Your assignment for today is you're going to be doing pages 594 through 596, and we're going to take a look at letters A through 24 for your assignment for today. So if you have any questions, sixth graders, please don't hesitate to reach out to me. I am here to help you the best that I can. If you need to go back and watch the video again to see certain aspects of it, please don't hesitate to do that as well. So good luck today, sixth graders. I hope you guys do really well. Reach out to me if you have any questions. If not, I'll see you with the next video.